In question 4, we have a hollow sphere with center C as seen, radius R. Let's create a radius R. A small marble rests at the lowest point, we can see here Q. And it's going to get projected horizontally. It's going to go up. At some point it's going to fall off when R is 0. Find the angle it makes with the downward vertical. So downward vertical, call this A. When the marble moves away from the inside surface. Okay, let's assume that it's less than 90. It might not be. So let's look at taking our particle here. We have mg. We have this angle at the center C. It's going to be corresponding with this one. So where mg is the diagonal, this will be mg cos A, and R will be here. So we're going to have R minus mg cos A is equal to mv squared over R. For my forces, my energy wise, we have mgh. Mgh starts at the lowest point, plus a half m by the velocity squared, which is just going to be 7g R over 2. That would be equal to mg. How far has it gone up here? Let's have a look at our diagram. It's now here. We have A, we have R. So this is R cos A, and the whole thing is R. So this has to be R minus R cos A. So that's how much it's risen by. So it's risen by R minus R cos A plus a half m times the final speed. When we simplify this down, we're going to get 7 mg R over 4 is equal to mg R minus mg R cos A plus a half mv squared. You can try to simplify it down a bit quicker if you want, but don't make a mistake. This is 1 3/4 minus a full one, so 3 mg R over 4. And then we will have plus mg R cos A is equal to a half mv squared. I find I do make a mistake if I try and do it too early, so just multiply by 2 now. We're going to get 6 over 4, or 3 over 2 mg R plus 2 mg R cos A is equal to mv squared. So we actually have mv squared over R, so why don't we equate to 2 mv squared over R? So we have R minus mg cos A, this guy, is going to be equal to, if we divide by R over here, it's going to be 3 mg over 2 plus 2 mg cos A. So R will be equal to 3 mg cos A plus 3 mg over 2. So when it falls off, the reaction is now no longer. So we're going to have 3 mg cos A will be equal to minus 3 over 2 mg. Dividing by mg at this point, we're going to get cos A is equal to minus 3 over 6 minus 1 over 2. And the inverse sine of a half, cos of 60, this will be 120. A will be equal to 120 degrees, so it does nearly gets to here about 60 degrees in the top before it falls off. And through what distance has it travelled? Okay, so we have the angle. Do we have an easy equation to sub it into? Yeah, let's travel to r minus r cos A. So it's traveled r minus r to the cos of A, which is minus a half. So it's traveled r plus r over 2, which is equal to 3r. 1.5 of the radius, 3r over 2 is in terms of r. Must be. Last part of this question.